Okay, I'd like to do page 267, problem A2. Now this problem, you can see on the side screen here, it says show each of the following is neither a validity nor a contradiction. Now a validity is the first order logic analog of a tautology, meaning a validity is something that's true in every interpretation, but and a contradiction would be false in every interpretation. An interpretation, recall, is a choice of you have to choose your domain, you have to choose any named constants, you have to pick truth values for any sentence letters. And when I say sentence letters, I'm referring to things like from TFL, and then a meaning. And by meaning, I mean the truth of all predicates. Meaning of all predicates. So, in other words, if I have something in my domain, or a combination of things in my domain, if it's a valued predicate, not valued, but variable predicate, then I should know how to find the truth value of whatever it is. Like, if I had R, A, B, I should know that that's true or false by the meaning of the predicate. So that's what an interpretation is. It's this list of things. So any interpretation must have these four elements in it. So in problem A2, we want to look at there exists X TXH. Now, it doesn't look so good, does it? There exists X TXH. I was looking at the screen when I wrote it. That's why it looks so bad. Okay. So we want to show it's not a validity and it's not a contradiction. So to show it's not a validity, we have to find an interpretation for which there exists X TXH is false. And that's because, well, if it was a validity, it would always be true, and so to be not a validity would mean there is an interpretation in which it is false. And to show it's not a contradiction, it means we need to find an interpretation for which there exists X TXH is true. And so that's all I have to do. And so I have to pick domains and so on. So, okay, so let's find an interpretation where this thing is false. So maybe my domain, I don't know, let's make it the Beatles. John, Paul, Ringo, George. And okay, that's my domain, and it says there exists X TXH, and that thing needs to be false. So let's let TXY be the statement. X is married to Y. Maybe I shouldn't say is, because some of them are dead. X married Y. Now, none of the Beatles married each other, so that's going to be false all the time. That predicate will always be false. Notice that the predicate here has a named constant. It has an H in it. So I need to give an element of the domain to H. Maybe we'll choose George, because George Harrison, that was his last name, right? So there are no sentence letters. We've given a meaning to the predicate. We've defined the named constant, and we've chosen a domain. Now, in this interpretation, there exists x, t, x, h is false. Right? Oh. There exists x, t, x, h is false. Because there is nothing in the domain that of these four people that married George. That's the case. So that's what we're talking about here. Okay? Finding an interpretation such that that sentence is false. Okay, so now we want to find an interpretation in which this, formula of first order logic is true. Okay, so again, we have lots of options. Maybe we just pick the same domain. John, Paul, George, and Ringo. And let's let TXY be X is in a band with Y, right? Let's say X was in a band with Y. Now I could put, John Lennon, Paul McCartney, and so on to make clear it was the Beatles, but when we think about, when we're assigning the truth values here, we're understanding that these were the Beatles, and so these are the four people in the band, the Beatles. Okay, and H is again going to be George. So in this case, I'll end up with there exists X, T, X, H is true, right? Because there is something in the domain with the property that that thing in the domain, it could be John, it could be Paul, it could be Ringo, it could even be George itself, was in a band with George. That band being the Beatles. So this is what we're talking about. Okay, the complete and utter freedom you have in it over an interpretation gives you a lot of options doing this kind of stuff. All right, let's look at another example. Wow, the wind is going crazy. Well, if you hear a crash, it's because of the wind. Let's look at A5. So A5 is the same kind of instructions. Show this thing is neither validity nor contradiction. And in this case, the sentence is for all x, WXMN or, and within the scope of that universal quantifier, we have there exists Y LXY. Okay, so we want to show this is not a validity, and we want to show this is not a contradiction. So not a validity and not a contradiction. And this is just a matter of making a decision about an interpretation. So we want to think of something in which this sentence is false. So now we have an or in here, and the only way we're going to get a false is if both of those two things end up being false in our interpretation. So maybe we'll pick three elements, okay, so let's do something like this. Domain, let's say the domain is apple, orange, and banana. And we need to define W and L in a way that they're going to be false. So W, X, Y, Z is a predicate. And maybe it's going to mean X, Y, and Z are vegetables, right? They're fruits. They're not, these things in the domain are fruits. They're not vegetables. So this predicate will end up being false no matter what we plug into it. And that's what we're trying to construct here, okay? So knowing the goal of what we want helps us figure out what we want to do. Now if we choose L in a way, also that's false. Maybe we say X and Y are, I don't know, universities, okay? I mean, it can be as ridiculous as you want. Then I think we can easily then say, in this interpretation, for all x, w, x, m, oh, we haven't completed our interpretation, right? We have two named constants in here. So let's let m be apple, and let's let n be banana. Okay? So that has to be part of our interpretation. Okay. So in this case, x, m, n, or there exists y, l, x, y, this sentence is now false under this interpretation because neither of these predicates is ever true for these things in the domain. So, okay, that pretty much does it by fiat. And a lot of these problems can be done that way by, if you're trying to show something is a validity or not a validity. Showing something is a validity is difficult because you have to go over all interpretations, but showing something's not a validity is as simple as making a single interpretation. And that general freedom you have, make it as easy as possible on yourself, okay? Because I saw I had 3 different letters maybe, so I made 3 things in my domain, and then I made 2 predicates that are always false for that domain. Now I'm going to do the same thing over here, except I'm going to make a domain and some predicates that are always true. Okay. Let's look at this other half. So to show it's not a contradiction, I have to come up with an interpretation of this sentence that's true. So let's say the domain is going to be Fairmont State WVU and Marshall University. Okay, let's say W, X, Y, Z is going to mean X, Y, and Z are universities. And let's let L, X, Y mean X and Y are in West Virginia, the state of West Virginia. Now let M and N, let M be Fairmont State, and let N be WVU. And now in this case, for all X, WX, MN, or there exists Y, LXY, this sentence is true. Over here it was false. I didn't write that. But here is true. Now why is it true? Because no matter what thing I pick in this domain, when that thing is substituted into this W predicate, it's going to say X, M, and N are universities. Every single thing in my domain is a university, so W is going to always be true. It's necessarily true predicate in this interpretation. There exists Y, LXY, well, that's going to say these things are in the state of West Virginia. All these universities are in West Virginia. So L is also always true. So I have, a true and a true. The OR is true, and that does it. That's all there is to this. You don't have to have some kind of interpersonal relationship between X, Y, and Z to define what a predicate is. All a predicate essentially is a decision about the truth values when the variables in it take anything that's in the domain. And if you can always make that determination from your interpretation, then you are done. That's all you have to do. Because we're really sort of doing a valuation kind of thing here, right? We're kind of saying, when you pick W Fairmont State, WVU Marshall, you're taking that to be true. If you pick W Fairmont State, Fairmont State, Fairmont State, you're taking that to be true. And we call it our universities because that's a simple way to make something that's always true. But the real power here is we are giving a mechanism to determine the truth of the predicate given certain domain elements being sort of plugged into it, so to speak. So those are letter A.